software. Okay, so in the remainder of the talk, I'm going to shift gears away from these demos and how to have trust negotiation with legacy services and talk about some harder trust management issues. Okay, so to motivate these, let's look at an example. So Alice has a company that makes some of its resources available to outsiders, but not just to any outsiders. So her issue is that she has to specify her restrictions on access to these resources, and we've kind of seen how to do that with the demos that we were just looking at. But she wants to do more. If she gives out information to some client, she wants to be able to tell the client what it can and cannot do with that information. In other words, she wants to control what happens with that information after it leaves her hands and goes off out into the internet. Well, that's pretty hard to do in the general case, but there are many scenarios where the client would be willing to follow her policy if she just had some way of explaining it to them and making it easy for them to satisfy the policy. And the reason many clients are eager to do such a thing is that there's been a lot of recent legislation that requires companies to have and enforce these types of policies, to track information as it flows through their organization and be able to certify that it's handled in an appropriate manner. So we've got a lot of clients who would cooperate if there was just some way for them to understand what they were allowed to do and not do with information and who they were allowed to send it to. So that's Alice's new issue, usage and redissemination conditions. And then on Bob's side, there's some things that he would like to do that he can't do right now. Sometimes whether or not you can get a service or get a piece of information depends on why you're asking for it. The purpose to which you intend to put that piece of information. If Bob had some way of describing his purpose of asking for information, maybe Alice would be willing to respond to more of his requests. Okay, so that's the first red item, purpose. And also, how can Bob find the credentials that Alice wants from him at runtime if he doesn't already have them in his possession? Is there some sort of broker he could go to or that Alice could tell him about that would help him? Or maybe he's got one of those credential wallets back on his home computer. How can he make the trust negotiation somehow involve his credential wallet back at his home computer? Okay, and how can Bob control what Alice does with the information that he discloses to Alice during a negotiation? So, for example, maybe he shows her his driver's license. That doesn't mean he wants her to just do anything she wants with it, like publish it in a marketing database. Maybe he should have some way to impose conditions on its future use. For example, yes, you can do what you want with it as long as you send me an email notification of what you're doing. Or no, you can't use it for marketing purposes. Those types of policies. And finally, how can he limit what information gets pushed to him? Sort of like a spam filter. Okay. So to rephrase these requirements a little bit more technically, Alice needs some help to meet her legislative requirements and corporate requirements. She needs distributed and scalable trust management, both for her legacy and her trust-aware services. And she needs ways to specify and reason about purpose of access, intended use, control of access, which we do know how to do, release policies, which govern who she's allowed to release certain information to, and redissemination of information after it leaves her hands and goes on to someone else. Well, Bob wants all those same abilities, plus he wants exposure control to limit the information Alice pushes to him and help in figuring out how to satisfy Alice's policies. So the research that we're doing that addresses these problems is called PeerTrust2. There is a PeerTrust1 that we worked on earlier when we first started looking at these issues. After maybe a few false starts, I think we have a really good solution approach, and we've named it PeerTrust2 to distinguish it from our earlier work. So PeerTrust2 is a logic-based framework for specifying purpose-based access, release, redissemination, and exposure control, and also for explaining how you could make use of helpful third parties in distributed systems. PeerTrust2 allows you to reason about all these ingredients at once. PeerTrust2 has a formal semantics, it has a proof theory, and this slide says it has an efficient runtime system, but actually it doesn't. That's not true. PeerTrust1 has an efficient runtime system. PeerTrust2 doesn't have any runtime system yet, because we've been working on the theory of it. So down at the bottom of the slide, there's a little diagram that shows how the situations that PeerTrust2 is intended for. We've got a bunch of peers, maybe offering services or being clients of services. The peers have a network that connects them, and inside each peer, the major parts are there's some sort of back-end knowledge base of policies and credentials, rules and facts. And when this peer communicates with other peers, there are filters that restrict the information that they can send to her that she's willing to accept, and there are filters that restrict what she sends out to other people. If we look at that in a little more detail, here we've got our three peers, Alice, Bob, and a little kid, and they can send messages back and forth to one another. And each of them has a knowledge base with the same basic structure. This knowledge base is layered. The bottom layer is first order, well, modal. It's modal, first order formulas. Looks a lot like data log with some modal operators thrown in. The layer above it, release policies and proof hints. That's second order. We'll look at examples of that in a minute. The release policies talk about what information Bob is allowed to send out to other peers. So anything in his base policies he can reason about locally, but some of the things he can reason about locally, he's not allowed to send his conclusions out to other people. Okay? So the release policies govern what he's allowed to send out. His proof hints talk about if he wanted to find a certain credential or prove that somebody has a certain property, here's where he should go to try to prove it or to find that out. That's what the proof hints are. Exposure policies limit what can come in and what can go out. That's especially important for kids and for spam control. And finally on top, there are event condition action rules that determine what types of queries Bob is willing to accept from other parties and what kind of answers he gives to those queries, how helpful he is or how uncooperative he is. Okay. So let's see. I think today I'll probably just talk about the base policies because the demos take a variable amount of time. They took quite a bit of time today, so maybe on a return visit I can talk about PeerTrust2 in more detail. But today I'll talk about the base policies. And to start us out, in the blue boxes, starting with the large blue box, we have an example of base policies written in the PeerTrust2 language. It looks a lot like data log, except for these signs and L signs that are thrown into the data log formulas. If we threw out that part of the formula, it would look like a normal fact, student of Alice, and a normal rule. X is a student if X is a student. Not a very interesting rule, but a rule nonetheless. So the new ingredient that we brought to this mix is this idea that formulas can be signed, directly signed or logically signed. And the intuition behind a signed fact, like registrar signs student of Alice, is that somewhere there is a physical signature that the registrar put on that fact. So the registrar actually cryptographically signed student of Alice. So it's a non-repudiable. If you receive this signed thing in a message, you can check the signature and you know that the registrar really did say that Alice was a student.